Welcome to HPE Nimble Storage Pure Persistence. Module 0, Course Overview. After completing this course, you should be able to describe HPE Nimble Storage Pure Persistence, describe the HPE Nimble Storage Synchronous Replication, describe how to configure HPE Nimble Storage Synchronous Replication, and how to configure HPE Nimble Synchronous Replication Witness, and enable Pure Persistence. You should be able to describe the testing procedures to locate documentation and resources related to HPE Nimble Storage Pure Persistence. This course consists of the following topics. Module 1, Product Overview. Module 2, Installation and Setup, with recorded demonstrations related to HPE Nimble Storage Pure Persistence Replication. Module 3, Synchronous Replication Witness Upgrades and Network Settings. Module 1, Product Overview. After completing this module, you should be able to describe HPE Nimble Storage Synchronous Replication, describe the Synchronous Replication Witness, describe Group Scope Target iSCSI Access, identify the supported infrastructure, hardware and network requirements, and describe the requirements checklist. HPE Nimble Storage customers' demand for an always-on enterprise is growing. Data growth is accelerating, and their dependency on data is increasing. Recovery service level agreements are transforming from days to hours to minutes. On top of that, there is a need for radical simplicity across the infrastructure and operations. HPE Pure Persistence allows customers to maintain continuous data availability with no data loss or downtime, even in the event of site-wide or natural disasters. HPE Nimble Storage combines synchronous replication and transparent failover with the power of intelligent storage for a peace-of-mind solution. Failover at the storage level is automatic and transparent with Pure Persistence. The hypervisors and applications do not have to be restarted, even in the case of a complete failure of an array. The result is an always-on resilient storage infrastructure for the hypervisors and applications. The Synchronous Replication Witness is a lightweight arbitration mechanism. The witness helps resolve split brain conditions that can occur because of network outages between arrays or in a Pure Persistence configuration. To protect data integrity, Pure Persistence is bidirectional. Configure the array in the primary and secondary sites to replicate to each other and mutually protect each other from failures. Host writes without replication. The host writes data to a volume on the HPE Nimble storage array. Data arrives in the NVRAM of the array's active controller. Data is mirrored to the NVRAM of the array's standby controller. The host receives acknowledgement from the array's active controller that the data is written to the volume. HPE Nimble Synchronous Replication requires two identical Nimble storage array models in the same group with separate storage pools. There is a maximum of 2 storage arrays in the group. Synchronous replication is not supported with HF20H, CS1000H, or SF series. The 2 systems are not required to have the same storage capacity and network options installed. Replication is performed on the 10 GigE IP replication paths configured for group traffic. Although Nimble OS will allow both data and group traffic on the same interface, it would be optimal to configure group traffic on separate interfaces as illustrated in the diagram. Mixing fiber channel hosts and iSCSI hosts is not supported. Note, replicating between systems with different capacity, cache, or network options could affect performance during failover scenarios. For synchronous replication, HPE Nimble storage arrays extend the number of copies of data that are written before the write operation is acknowledged to the initiator. If an initiator writes data to a volume that is configured for synchronous replication, the data lands in the NVRAM of the active controller on the array that is presenting the volume to the initiator. Next, the data is mirrored across the chassis backplane to the standby controller in the same array. And then it is copied across the IP interface to the active controller in the second HPE Nimble storage array. Finally, the data is mirrored across the array's backplane into the NVRAM on the second array's standby controller. Only then, after the data is successfully copied to all these locations, does the first array acknowledge to the initiator that the data has been written. Adding synchronous replication witness to the synchronous replication solution adds automatic switchover capabilities to the synchronous replication. When pure persistence is deployed, however, only one protocol is permitted on the HPE Nimble storage arrays in the group, and both arrays must use the same protocol. Nimble OS 5.1.x enabled group scope target iSCSI volumes. This is required for pure persistence. Existing iSCSI volumes can be converted from volume scope target to group scope target once the array is upgraded to Nimble OS 5.1.x or later using CLI. The procedure to convert is described in the HPE Nimble Storage CLI Administration Guide, version 5.1.x, available on InfoSite. Requirements for HPE Nimble Storage Pure Persistence is as follows. The two Nimble storage arrays must be the same model, but do not require the same storage capacity or networking options. Multi-protocol support is not supported when implementing pure persistence. Refer to the Nimble Storage Pure Persistence deployment considerations for Nimble OS 5.1 or later for details. As of Nimble OS 5.2 or later, the synchronous replication witness can be installed on an independent server or installed as a virtual machine. The round-trip time between the witness and each array must be 250 milliseconds or less. The default TCP IP port used for communication between the arrays and the witness is 5395. The host operating system must be supported and have the supported Nimble toolkit installed. HPE recommends having redundant links for replication and client access, and a minimum of two 10 gig E networks per controller for replication traffic. Information about network best practices is documented in the HPE Nimble Storage Deployment Considerations for Networking, Ethernet Best Practices. This is available on HPE InfoSite. These tables list the supported HPE Nimble storage arrays. Notice the HF20H, the CS1000H, SF100, and SF300 are not supported with HPE Nimble Storage Pure Persistence. Take a moment to review the table and click Play to continue. The operations listed on the slide are operations and features that are not supported with synchronous replication as of Nimble OS 5.2.1.0. Take a moment to review the list and click Play to continue. HPE Nimble Storage DHCI with Pure Persistence is supported. The following limitations apply when configuring Pure Persistence with Nimble Storage DHCI. 2 HPE Nimble Storage DHCI arrays are required. The arrays must be the same model and must be running the same version of Nimble OS. No more than 32 servers can be used for DHCI between both sites. The VMware vSphere cluster is spread across only 2 sites. 1 VMware vCenter server is required. Refer to the latest HPE Nimble Storage DHCI deployment guide for the most current information. As part of deploying HPE Nimble Storage Pure Persistence, there are many configuration details to consider. At minimum, verify the following conditions exist. The array group is running Nimble OS version 5.2.1.x or later in order to use the ASO capability. The 2 arrays are located within 100 kilometers of each other with 5 millisecond latency between the arrays. Redundant network paths are available between the 2 arrays for the management and replication subnets. The witness service is running on a host in a third failure domain with redundant connectivity to the array group's management network and a round-trip time of less than 250 milliseconds between each array and the witness. The witness server is configured in the HPE Nimble Storage Array Group's GUI or CLI, and ASO is enabled. The host must have a supported version of Nimble Connection Manager, Nimble Linux Toolkit, or Windows Toolkit installed. Module 2, Installation and Setup. After completing this module, you should be able to configure the synchronous replication witness on a bare metal host or deployed as an ESXi virtual machine. Set up the upstream and downstream Nimble storage array. Enable Pure Persistence and perform synchronous replication of volumes. You should also be able to perform a manual failover and recovery. Explain the failure scenarios and whether failover is necessary. You should also be able to explain how to restore replication after an array rejoins the group. Restore active paths for volumes after recovering from an automatic switchover operation, and be able to describe conditions that prevent an automatic switchover. The high-level process to deploy HPE Nimble Storage Pure Persistence is as follows. Review the current support and configuration documentation on HPE InfoSite. Verify the two Nimble storage systems are the same model, are running the same version of Nimble OS, and have the necessary PCIe cards and infrastructure. Configure the synchronous replication witness. Initialize the upstream array. Do not add the upstream array to an existing group. Add the downstream array to the upstream array group. Do not add the downstream array to the upstream array's storage pool. Configure the witness details in the group. Configure volume replication and test the configuration. The synchronous replication witness is required for peer persistence. It is deployed as an RPM on a server running CentOS, Linux 7.2.1511 or 7.7.1908. As of Nimble OS version 5.2, it is also available as an OVA, and it is supported with ESXi 6.5 with vCenter 6.5, ESXi 6.5 with vCenter 6.7, or ESXi 6.7 with vCenter 6.7. Please refer to the validated configuration matrix on HPE InfoSite for the latest information. To deploy the witness using the RPM, log into InfoSite to access the validated configuration matrix to verify the supported version of CentOS, and then download the witness software RPM. Install the witness software. A service called Nimble-WitnessD is created. Enable the witness process to start automatically when the system boots. Start the process and verify the process is enabled. Make a note of the port number as a firewall rule may need to be created. Create a username and password for the witness. Configure the Nimble storage array with the witness information. To deploy the witness using the OVA file, log into HPE InfoSite and verify you are running a supported version of ESXi and vCenter. Download the OVA file. The VM will have the following components: 1 CPU, 4 GB of RAM, 16 GB hard disk, 1 SCSI controller, and 3 VMXNet virtual network adapters. Log into the VMware vSphere client to access the VMware vCenter, where the OVA will be deployed. Right-click the VMware vSphere ESXi host and click Deploy OVF Template. Select Local File and choose the OVA file. Complete the deployment wizard. The net mask must be provided in the IPv4 notation. Power on the VM and complete the configuration. The first time you log in, you will use the root default password, which is provided on InfoSite, and you will be required to change the password. Next, configure the witness user and password. Important: do not deploy the witness client on a server that depends on one of the arrays in the peer persistence group for its storage. Download the synchronous replication witness from HPE InfoSite and log into the vSphere client. Right-click the ESXi server and click Deploy OVF Template. Select Local File and browse to the downloaded OVA file. Select the file and click Open, then click Next. Enter a virtual machine name and verify the location of the VM, then click Next. verify the compute resource, and a compatibility check is run. If passed, click Next. Review the information on the screen and click Next. Select the virtual disk format. In this example, I selected thin provisioned. Verify the correct data store is selected and click Next. Select the IP allocation setting and click Next. Enter the required network property settings. The net mask must be provided using CIDR notation. Once the required fields are complete, click Next. Review the settings and click Finish to complete the deployment. After the task completes, power up the virtual machine. This completes this demonstration. After powering up the witness virtual machine for the first time, the root password needs to be changed and the witness user configured. The default root user password is available on InfoSite. You will log in as root using this password. Next, re-enter that default password. Enter the new root user password and confirm the new root user password. Next, verify the Nimble witness service is running. Enter the command systemctl status nimble-witnessd.service. Now configure the witness user. Use the command user add space and the name of the user, in this case witness. Next, configure the password for the witness user. Use the command passwd space the username, which is witness. Enter the new password for the witness user. Retype the new password. And then verify the firewall settings are properly configured. The command is firewall-cmd-list-services. This concludes the demonstration. Watch the video about initialization of the upstream Nimble storage system. This video will demonstrate how to initialize and configure the upstream array for use in a synchronous pure persistence configuration using HPE Nimble Setup Manager. After installing the hardware and powering up the array, open the HPE Nimble Setup Manager, click the radio button for the array that is going to be initialized, and click Next. Click OK to continue the array setup in the browser. If your connection is not private page displays, click Advanced, then proceed to the unsafe IP address. The license agreement displays. Review the entire license. Then check the box that you agree to the terms and click Proceed. Select to set up the array, but do not join a group. Then click Next. Enter an array name and group name. Enter the management network settings. Configure the default administrator admin password. Then click Finish. After a few minutes, the initialization is complete. Click Continue to open a browser session to complete the initial setup of the array. A new browser session will open. If necessary, take the options to proceed to the unsafe IP address. Enter the admin user credentials and click Login. Remove the reference to the secondary management IP address. This will be configured when you add the downstream array to the group. Configure the management subnet. Then click the Add button to add the Data 1 subnet. Once the network settings have been configured for the Data 1 subnet, click the Add button to add the Data 2 subnet. Once the subnets have been entered, click Next to proceed to the next page. In this demonstration, the ETH1 port is configured as the first management port. Set ETH2 as the second management port. ETH3 and 5 will be configured as the Data 1 network. ETH4 and ETH6 will be the Data 2 network. Enter in the diagnostic IP addresses for the A and B controllers. Then click Next. Enter the domain name and DNS servers and click Next. Enter the NTP server information and set the time zone, region, and country, state, city to the location where the array will be located and click Next. Configure the support email details. It is a best practice to have email configured, send event data to HPE Nimble Storage Support, and allow HPE Nimble Storage Support to collect analytics data automatically from the array. Once this has been configured, click Finish. Once setup is complete, make a note of the firewall ports for outbound access and click Continue. This concludes this demonstration. This next video demonstrates how to group the downstream array and add the synchronous replication witness to the configuration. Log into the upstream array web user interface to add the downstream array to the group. Select Hardware, then Actions, and select Add Array to Group. Select the uninitialized array from the list. This array must be the same model as the upstream array. Enter an array name, then configure the data and management interfaces. Enter the secondary management IP address and the diagnostic IP addresses for the A and B controllers. Select Create New Storage Pool and enter a new pool name, then click OK. Once the array is part of the group, enhance the availability of the storage array group. Select Administration, then Availability. Verify the automatic switchover checkbox is selected. Enter the hostname or IP address of the witness and the username and password. Then click Save. Once saved successfully, test the connection between the arrays and the witness. This concludes this demonstration. Data replication. Nimble OS 5.1.x supports a maximum of 128 volumes per source storage pool for synchronous replication. This means that 128 volumes can be synchronously replicated from the group leader array storage pool to the backup group leader array storage pool. And another 128 volumes can be synchronously replicated from the backup group leader array storage pool to the group leader array storage pool. With Nimble OS 5.2.1.x, the maximum number of synchronously replicated volumes per storage pool is increased to 512. The next video demonstrates how to create an initiator group, replicate data, and monitor replication traffic. To create the iSCSI host, connect to the web user interface and select Manage, then Data Access. Click the plus sign to add the initiator group. Enter the host name and change subnets to use selected subnets. Click Add. Select both the Data 1 and Data 2 subnets. Then click Add to enter the initiator information. Enter a name for the initiator. Return to the desktop and open Nimble Connection Manager. Copy the initiator name to the keyboard buffer and return to the web user interface. Paste the initiator name in the IQN field and put an asterisk in the IP address field and click Create. Fiber channel initiators are configured using the port worldwide name of the host HPE rather than the IQN. To create a volume, select Manage, then Data Storage. Click the plus sign to create a volume. Enter a name for the volume Select the location for the volume. Select a performance policy. Enter the size of the volume and set data protection to not protected. Set access to the iSCSI host and click Create. Return to Nimble Connection Manager. If necessary, add the Nimble Discovery target. Click the Add button and select the group. Select the Nimble Volumes tab. You should see the Nimble group. Click Connect to connect to the group, and then click OK. After a few seconds, you should see the volume. Selecting Group, then Properties allows you to view the multiple paths to the group. Next, the demonstration will bring the volume online using the disk management. We'll also format the volume. After the volume is formatted, return to the web user interface and select Manage Data Protection. Click the plus sign to create a volume collection. Enter a volume collection name. Set the replication type to synchronous and set the replication schedule. You will also need to set the protection template. In this case, we will set it to no protection template. Click Next. Select the volumes to be replicated and click Create. After a few minutes, the initial synchronization will complete, and the remote recovery point will display as Now. We can now see the volumes for both the upstream and downstream array. When viewing the multiple paths using disk management, you will see the active paths to the upstream array and the standby paths to the downstream array. The demonstration will use Iometer to simulate some I/O traffic. We'll then return to the Web User Interface to view the performance graphs within the Web User Interface dashboard. Other performance graph views of interest within the Web User Interface are available by selecting Monitor, then Performance, or select Monitor, then Replication. This concludes the demonstration. Testing failover and switchover is important to verify configuration and host behavior during maintenance or failures. Both planned and unplanned failure scenarios should be verified. Before moving the first synchronously replicated volumes on an array group into production environments, it is a best practice to run a manual handover of at least one synchronous replication volume collection sourced from each pool. This enables you to verify the host that accesses a volume from one storage pool in the array group can also access the same volume when its active path moves to the other storage pool. To initiate a manual handover, navigate to Manage, then Data Protection, then Volume Collections. From there, select a volume collection, click the ellipsis icon, and select Handover. The demonstration will perform a controlled, manual handover between the replication partners. This process will verify that all connections work as expected. A handover instructs a downstream replication partner to become the upstream replication partner and provide the initiators access to the volumes. It allows the replication partner to take ownership of the volume collection from one pool to the other. A Lua is used, and a pause of a few seconds is to be expected. Select Manage, then Data Storage. Notice the upstream volume is in the default storage pool. And the downstream volume is in the Array-05 storage pool. Next, we'll use disk management to analyze the active and standby paths to the volume. Notice TPG1 is active optimized and TPG2 is standby. To perform the handover operation, return to the web user interface and select Data Protection. Check the box next to the volume collection, then click the ellipsis and select Handover. Verify the replication partner displayed is the partner pool and click Handover. A message displays indicating the handover started successfully. Notice the upstream volume is now on Array-05's pool, and what was the upstream volume is now downstream. Examine the volume paths in disk management. Notice TPG1 is now standby and TPG2 is active optimized. To restore things to their original configuration, perform another handover. This concludes this demonstration. This test will perform the steps necessary to validate the failure or disconnection of the witness. Open an SSH session to the array group's primary management IP address and log in with the admin credentials. Type the command group space -- info pipe grep space leader to determine which array is serving as the group leader. In the HPE Nimble Storage Array Groups GUI, navigate to Manage Data Protection Volume Collections and observe the direction of replication for each synchronously replicating volume collection. Using root credentials, log into the server that is running the witness service. Run the command sudo systemctl stop nimble-witnessd.service to stop the witness service. Log into the GUI for the HPE Nimble Storage Array group. If alarm banners indicating that the witness could not be contacted appear across the top of the screen, acknowledge the alarms and navigate to Administration Availability. Click Test to confirm that neither array in the array group can reach the witness. Back in the SSH session for the array group's primary management IP address, verify that the group leader role has not been moved to the other array in the group. In the array group's GUI, confirm the direction of synchronous replication has not changed for the volume collections. On the witness server, use the command sudo systemctl start nimble-witnessd service to restart the witness service. In the array group's GUI, navigate to Administration Availability and click Test to confirm that both arrays can reach the witness. Take a moment to review the list of tasks, then click Play to continue. Test failure or failover of the array's local controller. During a local controller failure or failover operation, no automatic switchover occurs. Controller operations resume locally on the partner array. Volume collections might briefly go out of sync, and automatic resynchronization might be required. In the HPE Nimble Storage Arrays Groups GUI, access the Hardware tab and select one of the arrays to drill down to its details. Before triggering a controller failover activity, Controller A reports active and Controller B reports standby. Use the same method described in the test witness failure or disconnect exercise to note the current group leader and current direction of replicating volume collections. A controller failover briefly pauses host I/O, but it's typically non-disruptive because the pause is well within SCSI timeout values for the host operating system. Non-disruptive controller failovers are one of the tools that HPE Nimble storage arrays use to enable controller upgrades and Nimble OS upgrades without requiring any array downtime. The standby controller can be replaced or updated to the new version of Nimble OS, and then that controller can be made active to permit upgrades to the other controller. On controller B, click Make Active. This action triggers a controller failover in which controller B takes over data services and transitions to a solo state while controller A reboots. The solo state indicates that the I/O mirroring is not taking place because controller B is missing its partner controller. After controller A is rediscovered, controller B becomes the active controller and controller A becomes the standby. Use the same method described in the test witness failure or disconnect exercise to verify that the group leader role and the direction of the replicating volume collections are unchanged. Test failure of a single replication link. If a single replication link fails, traffic automatically continues over the second redundant link. In the HPE Nimble Storage Array Groups GUI, access the Monitor Interfaces tab. This page displays bandwidth traffic for both inbound and outbound I/O on a per-port basis. If necessary, scroll down on the page to view the 2 ports that are designated for group replication traffic and click Real Time to observe the current traffic in detail. On the active controller, one of the arrays, disconnect the Ethernet cable that is plugged into one of the ports designated for group replication traffic. Reconnect the cable and confirm that the replication traffic spreads back against the 2 links. Test failure of all replication links. If all replication links fail and the witness is available, automatic switchover to the group leader array occurs and volume collections resynchronize automatically after links are restored. These are the steps needed to determine the current configuration of the array group with regard to the group leader role and the direction of synchronous replication, if any, for the various volumes in the 2 storage pools. It also explains how to observe how automatic switchover changes those properties while maintaining host access to the data in the synchronously replicated volumes. In the SSH session to the array group's primary management IP address, determine which array is currently the group leader. In the HPE Nimble Storage Array Groups GUI, navigate to Manage, then Data Storage, and note which volumes are labeled upstream or downstream for each storage pool. If a volume has neither of those labels, it is not being synchronously replicated to the partner pool. And if the array that is included in its storage pool becomes unavailable, the volume will be offline. Alternately, you can quickly check the direction of synchronous replication traffic by navigating to Manage, Data Protection, then Volume Collections in the Array Groups GUI, and view the list of volume collections. Typically, this is an easy way to digest the information about the volumes that are protected by synchronous replication, but it does not highlight the unprotected volumes. On the active controller of one of the arrays, disconnect the Ethernet cable that is plugged into each of the ports designated for group replication traffic. The array group detects that replication communication has failed, and after checking with the witness, it automatically switches the active paths for all synchronous replicating volumes to the group leader array. The volume collections report out of sync in the GUI of the array group, but all I/O to those volumes continues to be processed on the group leader array's copy of the volumes. Reconnect the Ethernet cables that were removed in the previous step to allow the replication traffic to resume between the arrays. The volumes gradually resynchronize, and the new state is reflected in the array group's GUI. After the volumes have resynchronized, the group leader array still serves the active paths for all the synchronously replicating volume collections. After remote recovery points have been created to restore the direction of replication to the pre-automatic switchover settings, choose the volume collections that need to be reversed and perform a manual handover one at a time. If you choose to skip the manual handover, check each volume collection to see whether the snapshot retention settings are valid for the current configuration. Typically, the volume collection data protection schedules are set up to keep more snapshots in the local storage pool than in the remote storage pool, but neither an ASO nor a manual handover changes the retention count for the storage pools when the role of the storage pool shifts from source to destination or vice versa. Test array failure. The failure of an entire array triggers ASO. The surviving array in the group performs group functions such as providing a GUI on the array group's primary management IP address, or providing access to data in the synchronously replicated volumes. The main difference between this test case and the previous one is the possible array failover of the group leader role to the backup group leader array, if the group leader array is the one that fails. To illustrate this behavior, this test case simulates the failure of the group leader array. Resynchronization occurs after the array is recovered and brought back online. As with the previous test for replication failure, manual handover of volume collections and possibly a manual transfer of the group leader role is required after recovery and resynchronization in order to return the array group to the pre-ASO configuration. Volumes that are not protected by peer persistence on the failed array remain unavailable while the failed array is offline. In an SSH session to the array group's primary management IP address, use the commands group space -- info pipe grep leader and the command IP space -- list to determine which array is currently the group leader and to display a list of all IP addresses used by the array group. In the GUI of the HPE Nimble Storage Array Group, navigate to Administration, then Availability, and verify that ASO is enabled and that the witness server details are configured. Click Test to confirm that both arrays can reach the witness. Unplug the power cords from the rear panel of the array to trigger both an AFO of the group leader role and an ASO of the active paths for all synchronously replicated volumes. As the array powers down, watch the primary management IP address fail over to the backup group leader array, using a ping command to monitor the array group's availability. After the group management services, including the primary management IP address, have been automatically failed over to the array, open a new browser session to the array group's primary management IP address, and again navigate to Administration, then Availability. Click Test to confirm that the management service is running on the expected array. Open a new SSH session to the array group's primary management IP address and use the same commands as in Step 1 to look at the details about that group. In the Nimble OS GUI, go to Manage, then Data Protection, then Volume Collections to confirm that all synchronously replicated volumes listed in the storage pool as the source storage pool and any volumes receiving data from hosts are out of sync because the destination storage pool is unavailable. Navigate to Manage, then Data Storage to examine the list of volumes. Notice that the volumes in the failed arrays storage pool are unavailable and that all the I/O is going to copies of the remaining array storage pool. ASO is considered a success because volumes remain online and application I/O continues after one of the arrays fails. To restore services to their former level, you must bring the downed array back online. Afterwards, the Nimble OS GUI should auto-detect that the array is available again and volume should start to resync automatically. As with the replication failure test, manual volume collection handovers may be performed after resynchronization is complete. Power on the downed array and wait as it rejoins the array group automatically and appears online in the hardware view of the Nimble OS GUI. Navigate to Manage, Data Protection, Volume Collections, and wait for the replicating volume collections to finish synchronizing. Navigate to Monitor Replication to confirm that all the volume collections have resynchronized and are ready for handover operations. Optionally, return the group leader role to the original group leader array, although there is no functional requirement to do so. To do this, open the SSH session to the array group's primary management IP. Run the command group space -- check _ migrate to confirm that it is safe to migrate the group leader role. Next, run the command group space -- migrate to perform the actual migration. As the group leader role moves to the other array, so does the primary management IP address. The current SSH session loses its connection to the array group when the IP address moves to the new group leader array. Open a new web browser session on the array group's primary management IP address and navigate to Administration, then Availability to run the witness test and confirm that the management service is now running on the desired array. For the final optional step in this test, use a manual handover to restore the direction of synchronous replication for each volume collection in the settings they used before the array failure test. Navigate to the list in Manage, Data Protection, and Volume Collections. Select a volume collection and then select Handover. This action restores the original active optimized paths for the volume to the array and storage pool to where they existed before the array failure step. Testing failover and switchover is important to verify configuration and host behavior during maintenance or failures. Both planned and unplanned failure scenarios should be verified. Manual failover when the group leader fails and ASO is not enabled. If the group leader array fails and ASO is not enabled, the group leader array can no longer accept any I/O requests for volumes that it is hosting. This means that any volumes on the array that are not being synchronously replicated to the backup group leader go offline, as do any volumes for which the pool containing the group leader array is the source for the synchronous replication. Because it cannot reach the group leader, and many of the array group functions rely on guidance from the group leader, the backup group leader array also takes its own volumes offline. In effect, the entire array group goes offline. If the group leader array is down and automatic switchover is not enabled, the primary management IP address becomes unreachable through either the CLI or the GUI. To manually fail over the group leader role to the remaining member of the array group, which is the backup group leader, you must open an SSH session to the secondary management IP address and log in with the array group's admin credentials. Using the secondary IP address will open a secure CLI session with the backup group leader. Run the command group space -- check underbar takeover to verify that the group leader array is not communicating with the backup group leader array, and that is valid for the backup group leader to assume the group leader role. If the takeover check passes, run the command group space -- takeover to transfer the group leader role to the backup group leader array. After the backup group leader array assumes the group leader role, it is no longer accessible through the secondary management IP address and the SSH session terminates. From this point forward, the surviving array becomes the group leader, and it is accessed through the primary management IP address for both the GUI and CLI administration. After logging a GUI session to the array group's primary management IP address, an administrator can see a series of alarms displayed at the top of the screen. These alarms are typically triggered by situations such as the following. Configuration synchronization with the failed array is delayed and will be retried. At least one volume collection that is synchronously replicating from the current group leader to the failed group leader is out of sync. Notification of group management service information to the failed array is delayed. The new group leader will continue to retry. I/O might be affected during this time. Or group management service is not highly available because none of the member arrays is able to act as backup. At this point in the process, all volumes in synchronously replicating volume collections for which the current group leader array was in the source storage pool are online but out of sync because the former group leader array is still unavailable. All volumes in the current group leader array's storage pool that are not configured for synchronous replication are also online. Any volumes on the former group leader array that were not being synchronously replicated remain unavailable, and all volumes in the volume collections for which the current group leader array was in the destination storage pool remain offline because the current group leader array's copy of those volumes is still the standby path. The volumes list shows the volumes that are available after manual failover of the group leader. Before changing the standby paths to active paths for that last set of volumes, you must modify their volume collections to remove the replication partner setting and, in effect, disable synchronous replication for those volumes. This modification must be made through the CLI because the GUI has no mechanism for this action. Start an SSH session to the current group leader array. Modify the volume collections. Note if any volume collections have multiple data protection schedules, the command must be repeated for each schedule. After all the data protection schedules for each of the synchronously replicated volume collections are modified so that the volumes on the current group leader are no longer referenced as downstream or destination in the array group's GUI, the volumes are available from the host to which they had previously been presented. When the failed array comes back online, it assumes the role of backup group leader, and the changes made to the volume collections are propagated to the returning array. When the changes are being applied, alarms might be displayed regarding out-of-sync volumes, but eventually the updated volume collections will take effect. Group leader failure restoration. Restoring the synchronous replication relationship after an array rejoins the group. After the array group configuration is stabilized, there are 2 copies of any volumes that had once been part of a synchronous replication configuration flowing from the original group leader to the current group leader. Neither copy is designated as upstream or downstream, and both copies are mounted to the same hosts. At this point, some additional work is required. To offline the volumes in the storage pool that has just come back online, navigate to Manage Data Storage Volume. Select each of the relevant volumes and set them offline. After the volumes are offline, edit each of them to remove any access control lists to facilitate using the volumes as synchronous replication destinations in a later step. Navigate to Manage Data Protection Volume Collections and select a volume collection that contains one or more of the volumes that were just offlined. Edit the volume collection to remove the recently offline volume or volumes and save the results. Edit the same volume collection again and designate the backup group leader's storage pool as the replication partner, then click Next. Select the copies of the volumes from the group leader's pool, add them to the volume collection, and click Save. At this point, the array group starts to resynchronize the volume collection when it is finished. Confirm that the remote recovery point in the volume collection list displays now. If desired, perform a manual handover of the volume collection to return replication direction to its original configuration by selecting the volume collection, clicking the ellipsis icon, and choosing Handover. This approach is considered best practice, especially if there's a plan to migrate the group leader role back to the other array, because it restores some measure of robustness to the array group. If the backup group leader array is serving the active paths for all the volumes for the array group, then the failure of the backup group leader array takes the entire array group offline, even though the group services are still available. Optionally, when the handover is complete and the replication direction is reversed, you can edit the volume collection to adjust the retention settings for the snapshots taken by the 2 replication partners. The retention counts are not automatically changed as part of the handover process. Optionally, you can migrate the group leader role back to the previous group leader array. A scenario in which the backup group leader array fails and ASO is not enabled is less disruptive than one in which the group leader fails. Because the group services are still available on the group leader array, not all volumes in the array group necessarily become unavailable. Technically, it would be possible for that to happen if the active paths for all the array group's volumes were pointed to the backup group leader array, but that would be considered a corner case. In this situation, all volumes in the backup group leader array storage pool go offline, including both volumes that are being synchronously replicated to the group leader array storage pool and volumes that are not being synchronously replicated. The volumes hosted in the group leader array storage pool remain online, although the volumes that are being synchronously replicated to the backup group leader storage pool go out of sync. The group leader array's copy of the volumes that are being synchronously replicated from the backup group leader array are online, but the paths to those volumes are the standby paths until manual intervention takes place. As with the case when configuring access to downstream copies of volumes after the group leader array failed and the backup group leader took over the group leader role, Before the standby paths are changed to active paths for the downstream volumes, their volume collections must be modified to remove the replication partner setting and, in effect, disable synchronous replication for those volumes. After all the data protection schedules for each of the synchronously replicated volume collections are modified so that the volumes on the group leader are no longer referenced as downstream or destination in the array group GUI, the volumes become available from the host to which they had previously been presented. When the failed array comes back online, it assumes the role of backup group leader, and the changes made to the volume collections are propagated to the returning array. While the changes are being applied, alarms might be displayed regarding out-of-sync volumes, but eventually the updated volume collections will take effect. Restoring after the backup group leader fails and ASO is not enabled, the restoration process is like the restore process described earlier. The difference is there is no need to migrate the group leader role back to the previous group leader. ASO versus manual handover. Although the process of installing the witness service might be a bit challenging, it more than compensates a storage administrator for the effort of facilitating automatic switchover. When one of the two arrays in an HPE Nimble storage pure persistence pairing fails, having the array group automatically fail over the group leader role when necessary and automatically switch over the active paths to the surviving array enables non-disruptive business continuity. Manually reconfiguring every volume collection that had been replicating from the failed array is a time-consuming and error-prone process. And if the failed array was the group leader, then all volumes remain offline until a manual failover of the group leader is performed. Restoration after an automatic switchover. After an ASO, when synchronization is restored to the volume collection, you can perform a manual handover of the volume collection if you want to move the active paths for the volumes in the volume collection back to their original storage pool. To hand over the volume collection manually, select a volume collection, click the ellipsis icon, and choose Handover. After the handover, examine the volume collection and adjust the snapshot retention values to match the desired behavior. When a manual handover is performed, the replication direction is reversed, but the number of snapshots that are retained in the local and remote storage pools does not shift in the data protection schedule. This demonstration will fail the source array and monitor the solution as pure persistence automatically performs the switchover. Iometer will continue to run during the failure. There's a slight impact during the operation, while the secondary array confirms with the quorum witness service to take over I/O. In this demonstration, we can see the volume is active on the upstream default storage pool, and the replica is on the downstream array. Reviewing the volume collection, you can see the remote recovery point is current and replicating synchronously. During the demonstration, the upstream array is powered off to simulate a failure. As you monitor Iometer, you will notice the IOs per second drop as the switchover occurs. The web user interface connection will also drop as the backup group leader is promoted. This operation occurs within a few seconds. Once the switchover has completed, you'll see I/O response times have once again begun to display an iometer. The web user interface will disconnect once the switchover occurs because the backup group leader is promoted to the group leader. The group leader is the system that is performing all the web user interface activity. Log back in to the web user interface once the switchover has occurred. You'll then be able to review any events and alarms that are being displayed because of the switchover activity. Notice also that iometer is still reporting that IOs are being transmitted and received. Select the Events menu to view the log and the alarm activity to determine what the problem is. In our case, we powered off the primary or upstream array, and a switchover has occurred. Select Data Storage. Notice the default volume is now the downstream volume. Array-05 is now listed as the upstream volume. Depending on your timing, you may need to reconnect into the web user interface. If that occurs, simply log back in. At this point, you'll notice that the system is reporting that the pp-array-04 is unreachable. Notice in the volumes page, you will also see that the volume is not available. And looking at the volume collection, you'll notice that it is now reporting that the volume collection is out of sync. Also, the hardware page will display that the array is not available. Launching Nimble Connection Manager and selecting the Nimble volumes, we'll now see that the group has a caution symbol indicating there is some type of problem. Looking at the target properties, we now see that the active paths are going over to the secondary array, and it's attempting to reconnect to the pp-array-04 paths. I/O is continuing to be accepted. I look at Disk Manager and the properties of that volume in Disk Manager. Will now display only TPG2 paths as active optimized. This is as expected. The TPG1 paths are no longer displayed because they do not exist. Now let's take a look at the peer persistence recovery process. During this section of the demonstration, the failed pp-array-04 comes back online. Once the hardware has been recognized by the system, we can take a look at the data protection. When looking at data protection, you will initially see that the volumes are out of sync. The resynchronization process begins automatically. In reviewing the volumes, you will now see that the original volume that was located in the default storage pool is now downstream, and array-05's pool now contains the upstream volume. Looking at the volume collection, once synchronization has completed, to return to the original configuration, perform a manual handover. Select the collection, the ellipsis, and then click Handover, verify the pool, and confirm. After a few minutes, the pool will fail over. Refreshing Nimble Connection Manager, you will then see all your active paths have now returned. And also verifying with disk management, you'll once again see that you have active paths to both the standby array and the active array, all while I/O continues. This concludes our demonstration. Conditions that block ASO are as follows. An unavailable witness. If the witness is unavailable, if there is a local failover of an array, or if a volume collection is out of sync, then ASO can be blocked. If the arrays in a pure persistence group cannot reach the witness service, they do not initiate an automatic failover or automatic switchover operation. In this case, the group leader array remains the group leader, and synchronous replication continues with both storage pools retaining their source or destination roles for each synchronously replicated volume collection. An alarm banner appears at the top of the Nimble OS GUI. If the witness is completely unavailable, alarms appear for every array in the group. You can check the witness connectivity at any time by navigating to Administration, Availability, and click Test in the Witness section of the screen. Although the witness service does not require extensive resources from its host server, it is still important to exercise due diligence in choosing a robust platform with reliable network connectivity to host witness service. The strength of these resources is key to ensuring availability. Local controller failover. If one of the arrays in the array group experiences a controller failover, no ASO takes place during the failover or while the array is running in a solo controller state. After the array resumes normal operations with active and standby controllers, ASO again becomes possible. Volume collections out of sync. If a volume collection is out of sync, it cannot safely be switched over, either by ASO or by a manual handover. ASO for that volume collection does not occur until all the volumes are synchronized. It is important to understand that if a volume is added to a synchronously replicated volume collection, all the volumes that are configured for synchronous replication go out of sync until the newly added volume is in sync. Module 3, Synchronous Replication Witness Upgrades and Network Settings. If an update to the Nimble OS requires a new version of the Synchronous Replication Witness service, there are two potential methods to upgrade the witness. Upgrade the current witness server, or replace the current witness server virtual machine with a new server virtual machine from the updated witness OVA package. Upgrade the current witness server. This method is valid whether the witness is running on a physical server or in a VM. It requires that the CentOS server on which the witness service is running has access to a CentOS software repository so that the yum utility can run successfully. In the HPE InfoSite portal, go to Resources, then Nimble Storage, and Software Downloads, and download the new Witness RPM package. Copy the RPM package to the CentOS server and log into the server using the root account. Use the following command to make sure the executable attribute is set on the file. chmod space 777 space and the RPM file name. Use the yum utility to install the RPM package. The command is yum space install space -y space and the RPM file name. Note that all dependent RPM packages are installed at this time, so internet access might be required. Run the systemctl space start space nimble-witnessd .service command to ensure the witness service is started. Replace the current witness server VM with a new server VM. This method is valid if you are replacing the current witness server VM on an ESXi host with a new VM containing the updated witness service. Because the yum utility is not used for this procedure, there is no requirement for the VM to have access to a CentOS software repository during the upgrade. In the HPE InfoSite portal, go to Resources, then Nimble Storage, then Software Downloads, and download the new Witness OVA package. On the Nimble Storage Array group, remove the configuration information for the current witness server. Log into the Nimble OS GUI, navigate to Administration, then Availability, and click Remove on the Witness section of the screen. Record any details from the existing witness server that will be used for the new VM. For instance, IP addresses or user account credentials that are to be reused should be saved for that purpose. Log into the existing witness server with the root credentials and run the command shutdown space -p space now to power off the VM. In the vSphere client, right-click the existing witness server and delete the existing witness VM from the ESXi host. Use the new OVA package to deploy the witness server. Following the instructions in the section, deploy the witness by using the OVA. On the HPE Nimble Storage Array group, add the configuration information for the new witness server. Log into the Nimble OS GUI, navigate to Administration, then Availability. Enter the details in the Witness section of the screen, then click Test to verify connectivity between both arrays and the new witness server. It is sometimes necessary or desirable to change the network settings for the CentOS VM that hosts the Pure Persistence witness service. If that VM was installed by using the witness OVA supplied by HPE Nimble Storage, HPE recommends completing the following steps. Remove the following files from the server: /opt/nimble storage /ovf set /state /state_set etc/sysconfig/network-scripts /ifcfg- and /tmp/ovf_env.xml. Shut down the server VM. In the vSphere web client, select the VM and navigate to the Configure tab. Select vApp Options. Change the network properties, the IP address, netmask, DNS, and/or gateway as desired. Power on the VM. This course has provided information detailed in the HPE Nimble Storage Pure Persistence deployment considerations for Nimble OS 5.1 and later, available on HPE InfoSite. It has discussed what HPE Nimble Pure Persistence is, how to configure an HPE Nimble Pure Persistence solution, how to test the solution before placing it in production, how to perform manual failover and recovery actions, how automatic switchover works, and how to maintain the synchronous replication witness. Thank you.